Hello amazing people, my name is Shreya Kadabgavkar and here's our another video. So today we are going to learn about working principles of simple artificial neural network. This presentation offers a visual guide to the basic architecture and working principles of simple neural networks. We'll demystify neural networks with clear and beautiful diagrams. First, we will see input layer, the starting point. It contains data integrity point or data entry point. The input layer is where data first enters the neural networks. It can be any type of data such as numbers, images, categorical data. For example, an image size 28 into 28 pixels would have 784 input nodes. Since 28 into 28 equals to 784. Next, feature representation of input layer. Each node in the input layer represents a single feature or attributes of the data. These values are then forwarded to the next layer of the network where computations begin. Next, we will see weights and biases, the learning parameters. First, weights. Weights are the parameters that adjust the importance of each input. Each input is multiplied by its corresponding weight. The network learns these weights during training and they can be either positive or negative, affecting the final output. The purpose of weights is to determine how much influence each input should have. Next, biases. A bias is a constant value added to the weighted sum of inputs before applying the activation function. Biases help the network learn patterns that don't pass through the origin. Means they are non-zero centered patterns and ensures that the model can make more flexible predictions. Next, hidden layers and activation functions. First, we will see about hidden layers. These layers perform complex transformations on the input data. Means each neuron in the hidden layer applies mathematical operations on the input data with the result passed to the next layer. The role of hidden layer is to transform the data in such a way that meaningful patterns can be learned. Next, activation functions. Activation functions introduce non-linearity to the neural network, which enables it to learn complex non-linear relationships in the data. Without activation functions, the network would essentially behave like a linear regression model, which is not sufficient for complex tasks. Common activation functions include, for example, ReLU, that is rectified linear unit, returns 0 if the input is negative and the input value itself if positive. This function is popular because it helps the model converge faster. Another example can be Sigmoid. It output values between 0 and 1. It's often used in binary classification tasks. Another example can be Tanh. Outputs values between -1 and 1 used for tasks requiring outputs that can be positive and negative. Next, output layer which helps in making predictions. First, final layer. The output layer generates the final prediction. The number of neurons in the output layer depends on the type of problem. First, for regression tasks, there's usually a single output node and the activation function is often linear. Second, for classification tasks, there are multiple output nodes in binary classification. There may be one node with a sigmoid activation in multi-class classification. There are multiple nodes and the softmax activation function is used to convert the outputs into probabilities. For example, cat versus dog, predicting whether an image is a cat or a dog. Next, forward propagation and loss function. First, forward propagation. Here you can see the diagram. During forward propagation, input data moves through the network layer by layer from the input layer to the output layer. Each neuron computes a weighted sum of the inputs, applies an activation function and passes the result to the next layer. This step continues until the network produces the output. Next, loss function. The loss function measures the error in the network's predictions. It quantifies the difference between the predicted values and the actual values. Ground truth, for example, in regression, a common loss function is mean squared error, that is MSE, which calculates the average squared difference between the predicted and the actual values. Next, backpropagation and optimization, that is gradient descent. Backpropagation. Once forward propagation produces a prediction, the network calculates how much each weight and bias contributed to the error using a method called backpropagation. This involves calculating the gradient of the loss function with respect to each parameter, weight and bias. The gradients indicate how much the parameters need to be adjusted to reduce the error. Next, gradient descent. This is the optimization process used to minimize the loss function by calculating the gradients. The network updates its parameters, weights and biases to reduce the loss. The update rule is W is equal to W minus N into gradient of L. W is the weight, N is the learning rate which controls how much the weights are adjusted, and gradient L is the gradient of the loss function. And learning rate controls the step size. It dictates how much weights. Just formula, weight is equal to weight minus learning rate into gradient. This is what the formula I just told. Next, training process, iterative improvement. First, forward and backward passes. Training a neural network involves repeated forward and backward passes. During each forward pass, the network processes the input data, and during each backward pass, it updates the parameter to minimize the error. Next, epochs. An epoch refers to one full pass through the entire training dataset. Typically, a neural network is trained over many epochs to refine its parameters and improve accuracy. Next, batch size. The batch size is the number of samples used in one forward and backward pass. Large batch sizes can lead to more stable gradients, while smaller batches provide more frequent updates but can be noisier. Next, overfitting. Monitor performance on a validation set. This helps prevent overfitting. In conclusion, I want to say the simple neural network works by taking input data, transforming it through several layers, adjusting its weights and biases based on the error, and improving its performance iteratively over multiple training cycles, that is epochs. The combination of forward propagation, loss function, backpropagation and gradient descent allows the network to learn complex patterns in the data and make accurate predictions. So, these are some interview questions that may be asked on this topic. First, what are weights and biases in neural network and why are they important? Answer, they are the core learning parameters. Weights adjust the influence of the inputs and biases allow flexibility by shifting the activation output. Next, what is the role of the activation function in a neural network? Activation functions introduce nonlinearity, enabling the network to learn complex patterns beyond just linear combinations. Next, explain forward propagation in simple terms. It's the process of passing input data through layers of the network to compute the output or prediction. Next, what is the loss function and how is it used during training? A loss function measures how far the predicted output is from the actual value. It's used to guide the learning process through backpropagation. Next, what happens during backpropagation? The neural network calculates the gradient of the loss with respect to each parameter, weights and biases, and updates them to reduce the error. Next, what is an epoch and how does it affect model training? An epoch is one full pass of the entire training dataset through the network. Multiple epochs helps the model learn better through the repeated updates. Hope you guys understand the concept. If you have any doubts, you can ask in the comment section. Please like, share and subscribe to my video and stay tuned. Have a good day.